Hi guys, I'm Pat Kelly. Okay, this is a great problem. I love this problem. I say that because you're going to see a couple of doses of reality here in this problem, and I don't mean to say that as some kind of ominous threat. You'll see what I mean. This problem keeps it real for us, okay? So they give us three parts, and in each part there's an integral that we have to find. And you'll also notice off to the side, what I have are the three integrals, which were like the main parts of the most recent lesson. And either in your head or even on paper, you probably would have had each of those three handy as you did the problems in this section. Because really the name of the game was trying to take the integral that was given to you and match it to one of these three patterns. So I do want to still have that option. Let's go ahead and do part A. Part A is the integral of 1 over square root of 1 minus x squared dx. And see, this is exactly what I meant, is if I see this integral, what I might think to myself is, can I get this guy to match one of these three templates? And if so, great, because my answer is just going to spit right out, okay? This is a really good one because it immediately matches that first one, right? My A is 1 and my U is x, and there's nothing else to it. This integral exactly equals immediately the arc sine of x. An indefinite integral, so we'll tack on our plus c for good measure. But that problem was a slam dunk. We're done. Okay, let's move on to part B. The part B, also indefinite integral. This time there's an x in the numerator. Does that matter? Of course it matters. I might still take the same approach and see if I can get this guy to match one of my three integrals from this section. I'll save you a little bit of frustration. Try as you might, you will not be able to, okay? Maybe you're going to try to get creative with some algebra. In fact, please feel free to try. It's never wrong to try to manipulate the given integral and see what you can make of it. But if your algebra is legal and legitimate, I'm telling you, it's not going to match any of those three integrals. So what am I supposed to do? Well, I can tell you, you actually could have done this integral a couple of weeks ago. All right? And this is that first dose of reality that I mentioned. Is you want to remember the old tools that you learned. Don't forget them. Don't forget how to use them. You could have tackled this integral a couple of weeks ago by starting with a U-Substitution of, let's say, U equals, and you might try different U equals. That also was a trial and error game at the time. But if you've gotten experienced at this, you might know that your U should equal everything on the inside of the radical, 1 minus x squared. So my du equals minus 2x dx. And so if I substitute, so that equals, if I do my substitution now, the integral, here's x dx. I'm only off by a minus 2. That's actually a constant factor, so we never really worry about that. In this step, if you don't mind then, let's actually pull it out in front of the integral. It'll become a minus 1/2 then. This x dx just becomes du. And this square root becomes the square root of u in the denominator. So let me write that as u to the 1/2. Because now it's actually the age-old power rule. We like this guy. This is just going to take the u, which is actually to the negative 1/2 power, bump it up a power, and divide by. So in my next step, I still have the minus 1/2 out in front. This u to the negative 1/2 bumps up to the positive 1/2, and you divide by that positive 1/2. And you'll actually see this is convenient for us. Those 1/2s cancel. And I'll tack on my plus c at this point and just go one more step to clean it up a little bit, because those 1/2s will divide out. I don't want to lose this minus sign, but also in this step I'm going to resubstitute for my u. My u equaled 1 minus x squared. So the negative sign, the u is supposed to be to the 1/2 power, so that would be a square root. I'll resubstitute 1 minus x squared, and then plus c. And we get it. Okay, so that's my answer for part B. Now let's move to part C. The integral of 1 over x times the square root of 1 minus x squared dx. All right, I might first start with that same strategy of, can I get this integral to match one of these three guys? Maybe the closest is this third option, because there is that independent variable that shows up outside of the radical in the denominator, and I have that, but notice inside the radical, the independent variable's in the wrong place for the subtraction. If I'm going to use this formula, my independent variable needs to be first, but it's second for me. Does that matter? Of course it matters, right? So I can't use that third formula for this integral. Try as you might, you're not going to be able to use the second or even the first. And I'm actually going to save you more frustration, because you can go ahead and play around with any of your old tools and none of them are going to serve you either. My gosh, what's going on here? If you go back and look at the directions, they even specify to evaluate the indefinite integral if possible. You can wrestle with this thing for an hour or two. It's actually worth the struggle. I'm going to tell you, you can't do this. It can't be done, at least not yet. My answer is that this can't be integrated. How about a nice pause for dramatic effect? Can't be integrated yet. Okay. All right. I enjoyed it. Hopefully you did as well. Try to compare that to some of the other problems that you'll see on your own. Okay?